Okay, good morning everyone. So myself Deobrata Kumar Das from Tumka Engineering College. Today we'll take the subject control system and we have discussed the topic is phase lag lead compensation network.
Okay, good morning, everyone. Am I audible?
Yes, sir.
Okay. Okay, so let's start. So we have discussed in our previous classes, this is the module 5, that is the compensation network design. And last two classes we have to discuss, that is the phase lag network and also phase lead network also. Another one, it is also third one we have to discuss today also. This is the very important, that is phase lag lead compensation network. Okay, so this is the phase lag lead compensation. So in this compensation network, we have to use both of the compensation design. That is, first one we have to use as the lead compensation, and as well as also we have to use as the lag compensation. So with single lag or lead compensation may not satisfy it, design specification for an unstable uncompensated system, lead compensation lead compensation provides fast response but does not provide enough phase margin. Whereas lag compensation stabilize the system but does not provide enough bandwidth. So, first of all, we have to also discuss in previous classes. So first we have to discuss lead compensation network and then we have to discuss the lag compensation network. So in this single connection, single compensation design, either it is lead compensation or lag compensation, we have to determine it is not satisfied the design satisfaction for our stability constant in our control system. So when you have to consider any unstable compensated system, when you have to use only single lead compensation network, so this network it is provides also this is a fast response, but it has a one disadvantage or little bit some error. That means the it is does not provide enough phase margin. So this is the one lack of the lead compensator also. And when you have to use only single lag compensation network, so in this lag compensation network, so it is the stabilize the system. Okay, also this is the stabilize the total system control system, but it does not provide enough bandwidth. So in this lag and leak compensation network, there are one problem is also arise. First, lead compensation network it has does not provide the phase margin, and lag compensation network it has does not provide the enough bandwidth. So we need to multiple. So in that case, so we need multiple compensators in cascade. Okay. So when you have to use these both compensation network, that is the lead compensation and lag compensation in both in a one system, this system it is called the cascade system. You know that we have discussed in our previous module, that is a idea I think module 2, that is a cascade feed forward network. Okay, so these are the basically called the cascade network system. Okay, so this when you have to use both compensation in a one circuit or one network, so this is called the phase lag lead compensation network. Okay, is it okay all of you?
Yes, sir.
So what is the circuit diagram? So in this circuit we have to use both of the circuit design. First lead network, another also lag network. So this is the circuit diagram. You know that previously we have to also discuss this circuit also. This is the capacitor. This is the one resistor connected here. Then this is the output terminal. Another, we know that here one resistor, and then one another capacitor we have to attach. Then this is the connection from here to here. Okay. So this is the input terminal. In our circuit, we have to determine that is EI, and this is the output terminal. You know that is the E0 or E output. This is the R1. This is the C1. This is the R2 and C2. Okay, so this is the basically circuit of the phase lag lead network. This is the phase lag lead compensating network. So here you can see this is the basically design of the first lead compensator, and another one it is also considered for here is the lag compensator. So when both compensator, that is a lag compensator and lead compensator, we have to connect it in cascade system, then this system it is called the phase lag lead compensation. Okay, so now we have to derive the expression of this phase lag lead compensation. So lag lead compensated, lag lead compensating network now let us determine transfer function for the given network and the transfer function, this is the transfer function t dot f, you know that is a transfer function, can be determined by finding the ratio of finding the ratio of the output voltage, you know that, to the input voltage. You know that previous classes we have to also discuss for the transfer function also. So now we have to consider in the given network in previous diagram, this is the basically phase lag lead compensating network. We have to calculate the transfer function from this given network also. Okay, so we know that this is a transfer function, it is a ratio between the output voltage divided by input voltage. So now you have to calculate from the given network. We written here that is the transfer function. So now we have to consider this transfer function. You know that this is a lag lead. So first we have to express here that is a G lag lead of the given system. So it is the ratio between the output of the system to the input of the system. So in the previous diagram, we have to calculate first lead compensating network and then also lag compensating. So this is the S plus 1 by R1 C1, then S plus 1 by R2 and C2 divided by here that is S square plus 1 by R1 C1 plus 1 by R2 C2 plus another 1 by R2 C1 into S plus 1 by R1 R2 C1. So this is the basically output to the input of the system. Okay, so this is the basically we have to calculate at both network. One is the lag network, another one is the lead network. So now we have to calculate this equation, that is you have to accommodate this equation, then the final equation it is done from here. We have written here, this is the transfer function of lag lead of the system. You have to calculate that the R1 C1 S. Okay, that is the R1 C1 S plus 1, this one. Okay, within bracket, another one R2 C2 S, R2 C2 S plus this is the 1, and this part R1 and C1 and R2 C2 it is also vanishing, that is a cutting down from these sections also. So next, this is this part R1, this you have to solve this equation, that is the R1 R2 then C1, C2 into a square, okay, plus then this part, that is the R1, C1 plus R2, C2 plus, then also R1, C2, R1, C2, S plus, this is the only one. Because now you can see this is the R1, R2, and C1, C2. These are the denominator part. This is the basically cutting from the upper section, that is R1, C1 and R2, C2. So these R1 and C1 and R2, C2, and here also denominator part R1, R2, and C1, C2, it is cut. Okay. So this is the only one it is based. So this is the basically transfer functions of the given network. Okay. Is it okay? Is it okay, all of you? So this is the basically transfer function of the lag-link network also. No one is confirmed. Is it clear?
Sir,
Yes.
sir वो 1 by R1 C1 plus 1 by R2 C2 plus 1 by R2 C1 का LCM लिया है ना?
और एक बार 1 by R1 C1 plus 1 by R2 C2.
Plus 1 by R2 C1 का LCM लिया है.
Yes, yes, yes.
Okay, sir.
Okay. So now you know that in previous configuration, that is a phase lag link network, when you have to consider, we have to substitute the alpha and beta. So this alpha and beta, you know that this is the basically attenuation constant in our compensating network. So now we have to write in the given equation on substituting the spelling is wrong, just wait. The first we have to write, we know that is alpha T1, it is equals to R1 C1. Okay, another one, that is also beta T2, this is the R2 C2. So now you have to consider from here R1, R2, C1, C2, we have to written, that is alpha beta T1, T2. This is simple. You have to multiply this one to this one. So these are the basically calculation from here. We have written alpha beta T1, T2. And when you have to consider that is T1, T2, this is equals to, you know that R1, R2, C1, C2. Because here this alpha and beta, this is a constant term. And this alpha beta, you know that it is basically attenuation constant. So where T1 and T2, this is the time constant, and alpha and beta, this is the basically attenuation constant. Sorry. Okay. So please remember these things also. So this is the basically we have to represent here both of the constant. One is the time constant, another one is the attenuation constant. So now you have to put this value into these equations also. Okay. So this equation is coming transfer function. So we written here transfer function of the given network. This is the G lag lead of the system. This is equals to 1 plus alpha T1s into 1 plus beta T2s divided by 1 plus, that is the T1s into 1 plus T2. So you have to put this value, that is T1, T2, alpha, beta, and so on, alpha T1, alpha beta T2. In the previous equation, the equation is coming, that is the transfer function in that. Okay, so now in this network, we have to consider both of the network, that is the phase lag network and phase lead network. So what is the pole zero diagram is coming? So diagram is coming here, you can see. Let us draw the pole zero plot for the above transfer function. So this is the basically real axis and another one imaginary. And we have to express in our compensating network, that is j omega, and this is, sorry, this is the delta. This is the delta, and this is the state of the plane. So now you need to know that in the phase lag link network, here 2 pole and 2 0 we have to consider here. That is, one is the 1 pole and 1 dominating 0. It is for the lead compensation. I am written here 1 pole and 1 dominating 0. It is for the lead network. Another one also lag network, 1 pole, 1 dominating 0. So that means 2 pole and 2 dominating 0. And we know that when the lead network, it is also another you have to consider for the dominating 0, then the system it is considered for the lead network. And when one dominating pole, that is 1 pole and 1 dominating 0 is present, and another you have to add it, the one another dominating pole, then this is considered for the lag compensation. So now we have to put, this is the 0, this is the another 0, and this is the another also. So this is the -1 by beta T1, this is the -1 by T1, this is the -1 by T2, and this is the -1 by beta T2. This is the basically pole zero plot of the transfer function of the phase lag lead network circuit. Okay, so this is very, very important to reduce the, it's classified that is a 2 types of error. This is very important. We reduce using this compensation network, that is the, we have to accept the enough phase margin from the given system, and another one, it is provide enough bandwidth. So these both error we have to calculate, we have to also increases using this phase lag lead compensation network. Okay, is it okay all of you? In your exam, that is semester question paper, this question, it is very, very important. Is it clear? So,
Yes, sir.
so what is the advantage? Now we have to consider for the advantage. Advantages of phase lag lead compensation or network. So first, due to the presence of phase lag lead network, the speed of the system increases because it shifts gain crossover frequency to a higher value. Another one, number two, you have to consider due to the presence of phase lag lead network, accuracy is improved. Accuracy is improved. So in this reason, we have to use in our control system for the stability operation phase lag lead compensation network circuit. Okay, so due to the presence of the phase lag lead network, the speed of the response of the compensating network or circuit, it is very much increases because it shifts the gain crossover frequency to a higher value because we have to use both of the network in the single circuit, that is the lag and lead network circuit. Number two, due to the presence of the phase lag lead network, so that means the accuracy is also improved. So this is the basically advantage of the phase lag lead compensating network. Is it okay, all of you?
Yes, sir.
Okay. So now, yes. Anyone any doubt or any questions? So please ask me. And now previously one of the student, but I am not known his or her name. The question is one doubt question, that is sending my WhatsApp. I am discuss also this question. So please, either he or she is present. So please tell your name. मतलब कल मेरे को एक व्हाट्सएप में क्वेश्चन दिया गया है आप लोगों की तरफ से, सर ये जो फेज लीड कंपेंसेटिंग नेटवर्क का प्रॉब्लम, तो मैं उस प्रॉब्लम को आज सॉल्व करके दिखाऊंगा आप लोगों को. सो प्लीज टेल योर नेम और हर नेम, क्योंकि उसके नेम मुझे पता नहीं, क्योंकि मैं यहाँ पे कौन भेजा है मतलब इलेक्ट्रिकल और ईसी डिपार्टमेंट, उसमें मुझे पता नहीं. तो ठीक है. So question is also this network, that is a phase lead network and lag network, these chapters. Okay, the question is, I am written here, the idea is given, the transfer function of a phase lead compensator is given by the equation transfer function. It is ds, this is equals to 3 into s plus 1 by 3t divided by s plus 1 by t. And given information, the frequency, it is also radian per second at which the angle of the phi, that is the phi m, you know that is the d j omega, it is maximum, is, यहाँ पे आप लोगों को ऑप्शन दिया गया है, ऑप्शन ए, दिस इज द रूट ओवर 3 by t square, option B, root over 1 by 3t square, option C, root over 3t, and option D, root over 3t square. Okay, so this question you have to given, this is a very good question in our this compensating network. So इसमें आप लोगों को देखो, what are the question, that is a transfer function you have to given, that is a phase lead compensator circuit. Okay, it is given by, this is the basically equations. Okay, this is the c into s into 1 by plus 1 by 3t divided by 1 by 3. And this frequency, it is also given radian per second, and which the phase angle, that is the angle of d j omega, that is the phase angle I m, we have to express in our network. It is a maximum in which condition? So you have to solve this equation. Okay, understand the questions? कोई response नहीं, ये मुझे बहुत बुरा लगता है, कोई response नहीं देता है, एक दो छोड़ के बस सब लोग चुपचाप बैठा हुआ है। ठीक है, तो इसको कैसे सॉल्व करते हैं? तो मैं यहाँ पे डॉट ये कर रहा हूँ, आंसर ऑफ द गिवन प्रॉब्लम. So the transfer function, we know that the standardized form of the phase lead network circuit, this is the transfer function of the phase controller is given by, we know that the system, that is GS equals to 1 plus A TS by 1 plus TS. Okay, so we have to also calculate in our previous stability analysis chapter. So we have to consider for the transfer function, this is the basically standard form. So now we know that where two conditions, where A is greater than 1, that is this A, okay, the value of A, it is greater than, it is 1, so it is for the phase lead controller or network. It is uses for the phase lead controller or compensating network. And when the value is A is less than 1, it is for phase lag controller circuit. Okay, and we know that maximum phase lead or lag frequency we represent in our here, that is omega m, it is equals to 1 by t root over of A. This is the basically formula of the maximum phase lead frequency, either phase lead or phase lag frequency. It is expressed as omega m, this is equals to 1 by t into root over M. And what is the phi angle? That is the maximum phase lead or lag, that is the phi m, you know that it is a phase angle. We have to express in our equation, that is tan inverse A minus 1 by 2 into root over A. This is the basically standardized formula we have to learn. Now, so you know that this is the basically given equation or given formula in our previous we have to discuss. Now you have to given the question, the transfer function, you know that this is the ds equals to 3 into s plus 3t divided by s plus 1 by t. Okay, now you have to calculate equations, that is 3ts. Here you can see I am solving here, that is 3ts plus 1 and divided by also 3 divided by this part, that is also ts plus 1 by t. Here you can see this 3 and this 3 cut, this t and this t cut. So the equation is coming, you know that, I think I am written here, that is 1 plus 3ts divided by 1 plus, we are arranging the equation. Okay, is it clear, all of you?
Yes, sir.
Okay, so now this
Yes, sir.
yes, thank you. So now this equation we have to express for the given network circuit, this part. So we have to written this equation. I am written here also. Okay, after this part also here. So it is the form of 1 plus a ts by 1 plus ts. This is the given format. So where we know that here a is greater than 1, because you know that a is greater than 1, that means this is a valid reason, valid value you have to calculate from here. And when a is less than 1, that means the a is 0, either is 0, that means this term is, it is also 0. Okay, so that's why we have to consider that is where a is greater than 1 for lead compensator okay. So the frequency at maximum phase lead, that is for the phase lead network circuit, we know that that is omega equals to root over, sorry, 1 by t into root over a. This is the basically phase lead frequency or lag frequency. When you have to consider for the a is greater than 1, that means this network is a phase lead, and when it is a is less than 1, that is also lag, because here you can see a is greater than, that is a is greater than 1, that is 3 is greater than 1. So that's why we have to consider this is the basically lead compensated network. Okay, so now you have to put the value, that is 1 by t into, what is the value of a? This is a 3. So this is the 3. Now we have to consider, that is omega equals to, we written this equation, that is 3t square. Okay, so this is the answer. So what is the option? I think option B is right answer. Root over of 1 by 3t square. Okay, is it okay, all of you?
Yes, sir.
Yes, sir. Yes.
Okay, so time is ending. So everyone please write your own name and roll number in the chat box also. And Gautam is present. Please response me, Gautam is present. Gautam is not present. So Jitendra Kumar, are you hear me?
Yes, sir.
So please you take a screenshot of the participant list. तुमको आता है ना?
ओके सर, हो जाएगा सर.
ठीक है, पूरा का एक पेज में आना चाहिए, उसको करके आफ्टर एंडिंग क्लास यू हैव टू सेंड मी. ओके, सो वी हैव कंप्लीटेड आवर कंपेंसेटिंग नेटवर्क. नेक्स्ट वीक आप लोगों का एग्जाम है, एग्जाम दीजिए. पूरा हर सिलेबस मतलब पूरा जो कवर हो चुका है उसी से आप लोगों को क्वेश्चन मिलेगा. और दो एक टॉपिक्स है दैट इज स्टेट स्पेस एनालिसिस, वो हम लास्ट क्लास में हम कर देंगे, दैट इज एक दो क्लास में उसको भी हम कंप्लीट कर देंगे। So best of luck for your exam. Okay.